Good afternoon, everyone, and welcome to Practice Final Review. We had some major technology problems this morning, and so I am just getting to go ahead and help you guys with what you're doing this evening, which would be 24 through 42. We may not get to cover it all, but I'm going to try my very, very best. So again, this is Mrs. Urso. Thank you for watching us and listening to us on YouTube. And this is the Practice Final. Numbers 24. We're going to take it till at least 39 at least today. When we want to factor a monomial completely, so if I wanted to factor 63 a cubed b cubed, I'm going to go ahead and I'm going to prime factor, and it's going to look like this: 3 times 3 times 7 times a times a times a times b times b times b. So please make sure when it tells you to factor completely that that is exactly what you are doing. If it asks us to factor 12g plus 20h, let's remember that there are two terms. There is no minus sign. The only way you can factor two terms with an addition sign is to find the GCF. You should remember to find the GCF, you're going to prime factor each term. Twelve prime factors is 2 times 2 times 3 times g, which is 12g. 20 factors is 2 times 2 times 5. So the GCF is what, guys? 4. The GCF is 4, which goes outside. Now, I'm not going to do every single problem totally and completely for you, but I think now you can figure out what's going to go on those two blanks. Yes? Yes. Okay. Yeah. And stay tuned tomorrow because we're going to give you all the right answers and show you completely every problem worked out, 26. I want to bring your attention. It wants you to factor it completely. So I think the easiest thing to do is if you guys would just find the GCF of these three terms. Once you find the GCF, the problem actually falls apart. So let's do that together. What's the biggest thing that 16, 8, and 60 all have in common? They all have a 4, and then they all have a j to the second power, which means if the GCF is 4j squared, there is only one answer that has 4j squared as my GCF. And so what I'm trying to show you is some hints that will help you not only taking this final exam, but taking ACTs and SATs. You don't even have to finish the problem, and the correct answer here would be what, guys? Choice what? A. Choice A is complete. Okay, on number 27, I'm just going to give a major hint. I'm going to let you guys do it. This is factoring by grouping, which probably at this point in the year most people have forgotten. So I would suggest that you FOIL your choices. FOIL choice A, B, C, and D. And when you FOIL choice A, you can see immediately that A is 3x plus y times 3x minus 2. That 3x times 3x gives me a 9x squared, so A definitely cannot be it, which means I'm now left with B, C, and D. And I'm going to let you guys finish that on your own, but I'm giving you some very major hints. 28. I think we can all factor a trinomial. We can all x factor, correct? And what multiplies to 14 and adds to 15 would be what, guys? 1 and 14. So it would be x plus 1 times x plus 14. Please feel free to work ahead on your practice finals. Okay, this is a great problem, and I spent some time on this in some of my other classes today. I'm glad we have some extra time and that technology is on our side. They want us to solve. So this is going to be a two-step process. You must factor first, and then you must zipper. So we have a trinomial, so we're going to x factor it. what multiplies to 56. If you know, please raise your hand. And at the same time, adds to negative 18. Multiplies to 56, but adds to negative 18. Yes? Negative 4 and negative 14. So my problem becomes r minus 4 times r minus 14 equals 0. I'm going to caution you for a minute. If you look at the practice final in front of you, you're going to see that one of the answers, one of the choices is negative 4, negative 14. And that is an incorrect answer. Those are the factors, but we didn't zipper it. If you know the correct answer, could you please stand? And that's a unanimous. So what would my real answers be, guys?
4 and 14.
4 and 14. So you see how this practice final is falling apart for us. There's going to be a couple of tough questions on the final just because of the nature of the material. But for the most part, you guys should be able to rock it. Number 30. Factor the trinomial. 3t squared plus 10t plus 8. So I would just go ahead. Because the coefficient is greater than 1, I would FOIL each answer. Let's see if you guys can remember. And I'm not trying to confuse you or tell you that C is the answer. But what do you call a trinomial that cannot be factored?
Prime.
Good. Okay, 31 and 32. I want to do 32 first because I think it's extremely simple, which is W minus 13 quantity squared equals 16. And we have 4 choices. Okay, so basically, this you would have to do by using the square root property. However, on an exam, on an SAT or an ACT, you don't have time, so we're going to plug the answers in. So let's start with A. What's 9 minus 13 give me? What's negative 4 squared? 16. A negative 9 minus 13 is a negative 22, and a negative 22 squared is not 16. So we can eliminate that. Let's try B. Well, we know that 9 works, but what's 13 minus 13 give me?
0.
That doesn't work. Let's try 9, 17. We know 9 works. What's 17 minus 13 give me? What's 4 squared? So my correct answer is C. Are you with me? Okay, 31. I'm going to spend some time here. D squared minus 10D plus 25 equals 6. This is my original equation. Let me just go on record as saying any quadratic equation can always be solved by which method works every time. The quadratic formula and or completing the square. Quadratic formula, remember one side has to equal 0, so you could subtract 6 from each side. But there's actually an easier way. You need to recognize that the left side is a perfect square trinomial. So that means what multiplies to 25 and adds to negative 10. So this would factor as D minus 5 quantity squared equals 6. What's the opposite of addition? Opposite of multiplication? What's the opposite of squaring something? Take the square root of each side. Okay, and you get D minus 5 equals plus and minus radical 6. Sorry. You want to solve for D. So you add 5 to each side, and your final answer here is D equals 5 plus and minus radical 6, which happens to be choice B. Personally, I think that's the hardest problem on the exam. All right, moving on. So let's get into graphing quadratic equations. Graphing quadratics. I think this is the end of chapter 9, if I'm not mistaken. Yeah, I'm pretty sure. This is chapter 9 still. Graphing quadratics. So the formula, or excuse me, the equation of a quadratic is y equals ax squared plus bx plus c. If a is positive, the graph opens up like a cup. If a is negative, the graph opens down like a frown. You guys remember that? Okay, so let's go ahead and let's look at this first example here, or this first problem. 33. Y equals negative x squared plus 4. Okay, so this class that I'm recording in, you are at a great advantage because you needed the least amount of help with the first part that we just went over, which means you're getting an advantage of me doing most of this with you, which means you have my permission to go ahead and finish the packet if you can tonight, or to work ahead as much as you can. Since I'm doing most of this with you, it'll only be to your benefit, and then we can ask and answer some more questions tomorrow. So here's my equation, y equals negative x squared plus 4. Please notice that there's a minus sign, which means the graph is opening up or down. Down. Okay, so the graph's going to look like this. So, for those of you that are watching online, I know you don't have my practice final in front, but we can eliminate the two graphs that open up, right? Okay, so now we have two choices. They are choice B and choice D. If you're not sure, let's go ahead and make a table. Let's pick some values. The first value you should always pick would be the number 0. And when you do, you find out that when x is 0, y is 4, which means your graph is going to look like this. If this is going to be my vertex, then my graph is going to look something like this, which would be choice what? Okay, again, I know I keep saying this, but do you see how the exam is falling apart in front of you? Does anyone have a question? Okay, the axis of symmetry. The axis of symmetry is found by using x equals negative b over 2a. So let's go ahead and do number 34 together. Y equals 2x squared plus 4x minus 6. And I'm just going to really be dramatic here and just show you and line up so that you know that y equals ax squared plus bx plus c. So what does a equal, guys? What does b equal, guys? And we don't need c, but what does c equal? Sorry. C equals negative 6. So, to find the axis of symmetry, we only need b and a. So x would equal negative b, which is 4, over 2 times 2, which is a negative 4 over 4. Or we could say the axis of symmetry is x equals what, guys? Negative 1. Now, in this particular question, they do not ask this, but the next question is a different equation, and they want you to find the coordinates of the vertex. So we're just going to find the vertex here. To find the vertex, you first need the axis of symmetry. And we just found the axis of symmetry. It was x equals negative 1. Then we're going to plug negative 1 into the equation. And this particular equation is y equals 2x squared plus 4x minus 6. That's going to help us find y. The x and y together is the ordered pair, and that is the vertex. So here we go. It's going to be y equals 2 times negative 1 squared plus 4 times negative 1 minus 6. For y equals 2 times 1, which is 2, minus 4, minus 6, for y equals what, guys? What's 2 minus 10? Negative 8. So my vertex has the coordinates of what, guys? Negative 1, negative 8. Are you all with me? Okay, so you should be able to do 35 on your own. Okay, 36. Solve the quadratic equation by finding the square root, round to the nearest tenth if necessary, or use any method. Okay, so I'm just going to tell you that 36 and 37, the left side, are perfect square trinomials. So you're going to factor it. Then you're going to take the square root of each side. So I already did one like that for you. That would have been number 31, right? Remember I did 31 for you like that? Okay, so you should be good. Okay, let's get on to the quadratic formula, number 38. Quadratic formula. And we can sing it together. Let's go. On 3. 1, 2, 3. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. All right. So there's the quadratic formula, and you can use that to solve number 38 for any method you want. But I want to draw attention to the discriminant. Do y'all remember the discriminant? We talked about that. The discriminant is the value of b squared minus 4ac. So if I was given this equation, this is number 39. And if it's n times the quantity, 8n plus 10 equals negative 15. So this is my original equation. I want to use the distributive property, which would give me 8n squared plus 10n equals negative 15. Then I'm going to add 15 to each side. And I get 8n squared plus 10n plus 15 equals 0. And now I need to locate A, B, and C. Who can tell me what A is? Class, what's A? What's B? What's C? Now we're going to plug that in to b squared minus 4ac. If b squared minus 4ac equals 0, there is one root. If b squared minus 4ac is greater than 0, there are two roots. And if b squared minus 4ac is less than 0, there are no real roots. Y'all remember this now? Okay, so let's see what happens when we plug it in. B squared minus 4ac would be 10 squared minus 4 times 8 times 15. 10 squared is what?
100.
And 4 times 15 is 60. And 60 times 8 is 480, which gives me a value of negative 380. Based on that number, that's the value of the discriminant. Based on my chart, how many real roots are there? 0 real roots. Does that help? Okay. It's amazing how much you actually do remember, but you just think you don't. I think I'm going to leave the next section because that goes to, well, that might be in this chapter too. I'm not so sure. Let's just see. I think I'm going to pick it up there. I'm going to stop there because the next section would be exponential notation and all of that. So we are going to end our party right here. Thank you for listening and have a wonderful evening.